Hi, what we're going to do is fill out that first page of notes that I gave you last Friday. What does integration tell us? We're going to learn about the applications of integration. So the first part we're going to do is a car problem. So I have a little car here that travels 50 miles an hour for 2 hours. How far does it travel? Well, you should know by part A that 50 miles an hour for 2 hours would be 100 miles. Pretty logical, I think. Now part B asks you to evaluate from 0 to 50 dt. Well, the integral of 50 dt would be 50t from 0 to 2. So plug in the 2, you get 100. Plug in 0, you get 0. 100 minus 0 is 100. Same answer. Part C says to sketch the velocity function v of t equals 50 for 0 to t and find the area. Well, the equation v of t equals 50 is a horizontal line up at 50 from 0 to 2. And if we figure out the area bounded right here, this area bounded is 100. That is not a coincidence. The next problem. An oil spill grows at a rate of 20 square feet per hour for 3 hours. The first question, how much does the oil spill grow? Well, if it's 20 square feet per hour for 3 hours, that gives you 60 square feet. If you evaluate the integral, this is part B, of 20 dt from 2 to 5, that's a 3-hour span. That would be 20t from 2 to 5. Plug in the 5, you get 100. Plug in the 2, you get 40. 100 minus 40 is also 60 feet. Well, 60. And part C says to graph r of t equals 20. R of t equals 20 would be a horizontal line right there, horizontal line of 20. And if we look at the area bounded between t equals 2 and t equals 5, that would be this area right here, which is 3 by 20, which is also 60. Part 3 is a similar problem, but a slightly different rate. Notice that an oil spill grows at a rate of 20t square feet per hour. So if we were to start by actually just sketching 20t square feet per hour, that's a line with a slope of 20 and a y-intercept of 0. 1 would go to 20, 2 would be 40, and 3 would be 60. So this time the area under the curve, this area right here, is a triangle, 1/2 base times height, which would be 90. If we evaluate this function from 0 to 3, we will get, let's see, that's 10t squared from 0 to 3. Plug in 3, we'll get 90. Plug in 0, we'll get 0, which again gives us 90. But what if we evaluate this particular function in a different window, a different 3-hour window? In a different 3-hour window, the integral from 20t dt will still be 10t squared, but this time going from 1 to 4, that would be 4 squared, which is 16, 160 minus 10, which this time is 150. Now, why is it different? Well, it's different because the first two functions were constant functions, whereas this third function is a function that has t in it. Notice, not 20, but 20t. So let's go back and think about this. When we looked at either the area under the curve, which we know is what integration does, or we evaluated by integration the rate of the car, or let's say, the car was velocity. Okay, so the velocity of the car, we got the distance traveled. When we integrated the rate of spill, we got how much the spill changed by. What does that mean? That means an integral allows us to find how data accumulates. If you integrate, let's say, a rate of people entering Great Adventure, in like people per hour, if you integrate that over a certain number of hours, you will get the total number of people who enter. You'll figure out the accumulation of people entering or leaving the park. If you integrate, a rate of filling of a bucket with rain over a time period, you will figure out how much water fills, or how much water goes in the bucket. So the thing to remember, really, this is the most important thing, is that integration tells you about accumulation. So look at the next equation. If W prime of t is the rate of growth of a child in pounds per year, okay, what does 5 to 10 of W prime of t dt represent? Well, if we know this is pounds per year, I would assume that these two numbers are years. This would tell us the change in weight of the child, but let's be specific, from age 5 to age 10. Remember back with the oil spill, how I didn't mean to do that. How the first 3 hours as compared to hours 1 to 4 had different changes in the spill area. That's why we want to be real careful and include the age representation. So let's look at the next problem. If oil leaks from a tank at a rate of R of t gallons per minute at time t, the integral from 0 to 120 of R of t dt will give you the number of gallons that leak from that leak, let me spell that right, t equals 0 to t equals 120. Okay, so just make sure you have that first page filled out, because in class we're going to work on the integration problems on the next 3 pages. Have a good rest of your weekend, and I'll see you on Monday. Bye.